Hello everyone, my name is Onet, and a quick introduction about me. I completed my DSATs back in 2024, scoring in the 91st percentile. I did my Cambridge O-levels in 2023, followed by my Edexcel International Advanced Levels in 2025, where I achieved excellent results in all of them. For my A-levels, I did chemistry, physics, mathematics, and further mathematics. I did 6 units in chemistry, 6 units in physics, and a total of 13 units in mathematics. I'm currently 18 years old. I recently graduated high school, but I have already been granted admission and a scholarship to my dream university, where I'll be pursuing my bachelor's in electrical and computer engineering. Now, to the lesson, I want to give a brief, small introduction about differentiation. Now, differentiation is all about finding how a function changes. It's about the rate. It's about how fast it's increasing or decreasing at a specific point. Now, the result of differentiation is known as the derivative. Similarly, the result of integration is known as an integral. For example, let's consider this graph. This is a simple y equals x squared graph. If you differentiate this, dy over dx or f dash x will be 2x. You obtain that through the basic nx n minus 1 differentiation rule. Now, once you differentiate this and you get the 2x, if you plug in any x coordinate of your choosing, for example, if I plug in 2, for this case, for this graphical representation, you will get the gradient or the slope or how the function changes at that specific x coordinate, which is 2. So at x equals 2, the gradient of the graph is 4. Now, differentiation can be used for a whole different array of concepts. It can be used for graphical representations. It can be used for real life concepts like fluids flowing. It can be used for example, water flowing into a tank, the flow rates, the flow speeds. It can be used for a whole different set of applications. Now, if you put that aside, differentiation dy over dx, there are three major rules. You have the chain rule, you have the quotient rule, and you have the product rule. Now, the chain rule is used when there is a function inside of a function. For example, y equals sine 3x. A quotient rule is used when there are two functions in a fraction. For example, there is one fraction in a numerator and another fraction in the denominator. The product rule is used when it's a multiplication of two different functions. Now, I want to get to the topic that I want to discuss in detail. Now, the product rule, these are the key concepts. When is the product rule used? What is the formula? And what is the method along with the key idea? Now, the product rule, you use the product rule when you're differentiating a function made up of two separate functions. Now, that would be in the form of y equals ux times bx. There is a repetition of x. For example, if you look at this example here, x squared sine x. You see a repetition of x. You see the x squared, and then you see the sine x. Now, these type of problems are very different from simple y equals x squared, y equals x to the power 3. Uh, it is different. So when you see problems like that, your mind should automatically resort to the product rule. Uh, the formula is quite simple. Formula is dy over dx is equal to v du over dx plus u dv over dx. It's easier to keep it in your head if you remember it as first times the derivative of the second plus second times the derivative of the first. First times being v times du over dx, where du over dx is the derivative of the second and v is the first, and vice versa. Now the method. Once you realize that product rule has to be used here, the first thing you need to do is identify your B and your U components. Now, if you take this example, it doesn't matter where you break it, and it doesn't matter where you break it and categorize it. Now, x squared can be b or x squared can be u. But just make sure that you separate the two accordingly. And then what you must do is just differentiate them. Just differentiate them with respect to x. Find dv over dx and find du over dx. And after you find them accurately, just plug it in into the equation, and then you will find your dy over dx. Simple as that, and that's it. That's product rule done. Now the key idea, you need to realize that when two functions get multiplied, both of them will change. Both of them will change with respect to x. Now the product rule, what the product rule does is it considers the rate of change for both of them. It will account for both rates of change. How the first changes when the second stays the same, and vice versa. How the first stays the same while the second changes. Now, this statement is quite literally this, because how the first changes. Now, derivative of the second right here, that is just how the second changes. First times how the second changes. Just uh, which is basically the same thing right here. So that is a quick overview. That is a quick recap about the product rule.